AMA Lesson 2.3, Day 1. Today we're going to learn how to take derivatives, but where we're going to be using two very special rules. The first one is the product rule. The product rule is when you take the derivative of a product of functions, f of x times g of x. The product rule will be, and you want to have this memorized, very simply, it's f of x times the derivative of that second function plus, then we can take f prime of x, the derivative of the first function, multiplied to the second function. What you're going to see is you're always going to have the derivative of one function multiplied to the original other function. So you're going to have that addition of the two. Order does not have to go this way. We could have started with that second grouping first, but this is really how we're going to proceed. We're going to go ahead and take f of x and g of x right here. We're going to take our derivative, and of course, as we do that, we're going to first have f of x times g prime of x. So our f of x is x to the 2/3. And then what's the derivative of g? Well, that's going to be 4x to the 3rd minus a 1. The derivative of x is just a 1. And then we're going to say f prime of x times g of x. Well, f prime, is we take the derivative of x to the 2/3, we'll say 2/3, but then we have to subtract 1, and we know that 2/3 minus 1 would be negative 1/3. So we'll have x to the negative 1/3, and then we're going to multiply that to the original function, x to the 4th minus x plus 2. What we're going to do at this point is distribute and try to group like terms together. Let's see if we can do that real quickly. Remember this exponent property. When you have x to the m times x to the n, you're going to add the two powers together. So 2/3 plus 3. Well, we know that 2/3 plus 3 is really like 2/3 plus 9/3. That's x to the 11/3. And multiplying by 1 would be nice and simple. We'll just have x to the 2/3. Then as we distribute here, we'll have a 2/3. But 4 with a denominator of 3 becomes 12/3. 12/3 plus negative 1/3 is actually 11/3. Then as we distribute here, 2/3 times x to the negative 1/3 times x to the 1 with a negative out in front, we'll have a minus 2/3. We're going to add negative 1/3 and 1. You can see that's actually going to get you x to the 2/3. Finally, last distribution, 2/3 times 2, you'll get 4/3. And here's your x to the negative 1/3. So let's put our like terms together. For our 11/3, we have 4 and a 2/3. Again, 4 is 12/3. 12/3 plus 2/3 is going to be 14/3. Then we can group our x to the 2/3 powers together. We have a minus 1 and a minus 2/3. A minus 1 is negative 3 over 3. Minus 2 over 3, that would be a minus 5 over 3. And then finally, the last term doesn't have anything to group with it. We could leave our answer like this. If the direction said no negative exponents, we'd have to bring our x to the negative 1/3 down. Really what we're going to see, I'm just going to set up the quotient rule, and then we're going to be able to move on. With this quotient rule, we can see if we're taking the derivative of one function divided by another function. We can have a high function and a low function. So here's a little saying that can help you out with this quotient rule. You're going to have to memorize this. It's the low function d high, the derivative of the high function, minus the high function, f of x, derivative of the low, all over the low function squared. And the little saying that we can have to help us out is low d high minus high d low, all over low squared. Low d high minus high d low, all over low squared. So when we say something like low d high, the d, of course, means derivative. So low d high minus high d low, all over low squared. Once you have that worked out, of course, you're going to be able to go pretty quickly. So let's just take a look here. A lot of times, because f of x itself is used as a function, you could see this written out instead. U over v with a prime. We'll say low d high minus high d low, all over low squared. Well, you can see that we've got our u is 3x minus 1. Our v is 2x plus 1. And as we take this derivative, we can say we've got our low, that's 2x plus 1. D high, what's the derivative of the high function? Well, just a 3. Minus the high function, 3x minus 1. D low, well, the derivative of the low function is just a 2. And then that's all over low squared. Well, we're going to go ahead and just clean this up and see what like terms we can put together. We're going to distribute this 3 here. We'll get 6x plus 3. Tell you what, when we're looking here, it's as if we're really distributing a negative 2 to the 3x minus 1. Of course, we've got a negative 1 right here. We've got the 2. Together, they make negative 2. And when we distribute, we'd get a minus 6x. Negative 2 times negative 1 is a plus 2. And then down below here, we have 2x plus 1 squared. You can see our final answer will be nice and simple. Just a 5 all over 2x plus 1 squared. For our last problem, for example 3 here, here's the problem that we're going to have. We don't know how. Obviously, we look at y as 1 over 3x plus 5 to the second. And as we're trying to figure this out, we don't know how to take the derivative of that low function just yet. We are going to figure that out a little later, very, very soon, how to deal with an expression raised up to a power. This looks like we've got the quotient rule. This last problem will be a combination of the product and the quotient rule. So what we can do is just say, look, when you square something, you're really multiplying that to itself. So let's just go back up to the product rule where, and in fact, I'm going to, off to the side, give us a little reminder. What was the product rule? This is kind of like our two functions here. Well, we could have our first function times the derivative of the second plus the derivative of the first function times the second. How did we go about doing the quotient rule? If we had f over g, well, that was low d high minus high d low all over low squared. We're going to bring these two together. First, we're going to have to just write this out. As we take our derivative, let's just apply the product rule. We'd say we've got our original function, and tell you what, then I'm going to say this. We'll deal with this derivative in just a second. We'll say take the derivative of that second function. That's kind of like your u v prime. And then we're going to say take the derivative of that first function. Now, ironically, it's the exact same thing, isn't it? Times our second function. It's kind of nice in this regard. Our first and second functions happen to be exactly the same. But now what? Well, we can go off to the side and say, you know what, is we're taking the derivative of that second function here of this 1 over 3x plus 5. We can see that it's really kind of like f of x was equal to 1, and g of x was equal to the 3x plus 5. And we're going to go ahead and use that quotient rule. So we'll say low, that's 3x plus 5. D high, well, what's the derivative of 1? Well, that's going to be a 0. Minus, so we did low d high minus high d low. And what's the derivative of that bottom one? Well, that's just a 3 all over low squared. So it's low d high minus high d low all over low squared. The cool thing is you just did all this work for that derivative off to the side. You know what? You're doing the exact same thing over here. It's really going to be exactly the same setups. And wow, look at this. Multiply anything by 0. That completely wipes out. So what do we have? We're going to have negative 3 up here. And by the way, we'll have a 3x plus 5 times a 3x plus 5 squared. That's going to be 3x plus 5 cubed. And when you come over here, you're going to see it's exactly the same thing, because we're really dealing with the exact same expressions. What's your final derivative? Final answer, negative 6 all over 3x plus 5 cubed. Combine your like terms. Okay, so our homework is going to be on the worksheet that we're providing, and I'll put that up on the Google Classroom too, 1 through 33, the odds.